Hi, I'm Yusuf. In this video, I will tell you the contour array operation. You can access it from directly this symbol or from fixed contour array link. It's a finish operation, but we used this Z-double profile before as a finish operation. What's the difference between contour array and Z-double? You can see the difference from the pictures of these operations. It is the contour array is used for generally non-steep surfaces, and Z-double profile is used for generally steep surfaces. The parts can contain both steep and non-steep, but if there are mostly steep areas, we use Z-double profile, and if there is mostly non-steep surfaces, we use contour array. We choose our tool. If I don't choose any cut area or trim boundaries, all the surfaces will be machined. So I must choose a contour area, but choosing the all areas will take too long. So I use a trim boundary. I choose it. I use face side trimmed outside and choose the bottom of the parts. So the tool paths won't be created outside this surface. I edit the parameters. Follow periphery, constant 1 millimeter. First I choose on plane and click OK. We used the boundary in the same parts, and we had the same tool paths. Because the fixed contour logic is like this, it creates the tool paths and projects it to surface. But RMLink is better than boundary, because they aren't these gaps aren't acceptable now. Step over applied and on parts and click generate. The software closes the gaps by creating tool paths between these gaps. So I have a very good surface quality, because the tool machines, the tool touches to all surfaces. I can change it to zigzag and vector, specify 45 degrees and click generate again. As you can see, the gaps on Z-double profile is closed too. If you want to enlarge the tool paths a little bit, if you remember, we do it from here, for example 2 millimeters. Okay, and generate. It will not work at first, because we make a boundary for it. We use stock and we define -3. Now we enlarged the toolpaths. We extended the toolpaths. It is a little bit for this part because it moves down. We should use, for example, .5. It will be enough too. Okay, let's look other parts. We used Z-level profile on the formed surfaces, and we had those engage and retracts. We were avoiding this by stagger ramp on parts. We again have those small engage and retracts, but the general toolpaths are good, I think. Let's do this with contour area. Insert operation. I use follow periphery first. Outward, it will start from the top. Constant 1 millimeter, and on parts. Now, in contour area follow periphery, we just have two engages and two retracts. No, there are more than two. It makes engage in flat surface, in 4 flat surfaces and 1 top. You can use it instead of Z-double. In those steep areas there are some I don't know, mistakes, I think, but in contour area they are better. You decide what to use. Let's change the pattern. Zigzag. You can use it too. The engage and retracts are at the bottom of the surfaces. You can use both Z-level profile and contour area in this operation. Let's look at other parts. We used Z-level profile on machining these formed areas, and let's do it again. I will not change the cut direction to mixed to compare with the follow periphery. For one direction to make the climb a move, it always have to get back to its initial place. I click OK and I choose contour area. And choose follow periphery. And one difference is I make everything from this edit, and in Z level I change many places in cut levels, cutting parameters or non-cutting moves. I click generate. And I can see very less engage and retract moves here. But the one disadvantage on this operation is you have these plunge moves, and it isn't good for tool or parts. In steep areas, the tool must move as Z-level profile. It must make a profiling move, I think. But this is used in many places. This follow periphery operation is used in many machine shops. Let's look at other parts, cut regions too. First, I make the Z-level profile. I choose the cut areas. Cut between levels. Okay, and generate. For managing the one way cut direction, it makes this lifting moves. It should make this lifting moves. And in non-steep areas there are follow periphery moves, so these cornered moves, corner toolpaths creates these signs in part surface. And let's do it with contour area. Okay. I click follow periphery, constant, dot 0.5, and on parts. You can see that there is just one engage and one retract here. This circular move is created because of this surface. If I make extended edges, it will not be here. Okay, but the same toolpaths will be the same plunge move will be here, but it doesn't make so much problem here. Let's get to the last part.
IT manager.
Our last part has very deep, steep areas here. Let's delete old operations. In classical machining methods, we use very long tools that access the all areas, but the disadvantage in this method is you have vibration because of long tools, so you the tool's life will not be enough for machining the all surfaces. Let's make this move. Tangent faces, okay. Allow periphery constant 1 millimeter on parts. In theory, it is very good operation. As you can see here, the tool enters from one, engaged from one point and retracts from one point. But as I said before, like these parts that have very deep areas generally can't be machined with just one tool because of vibration and other issues. So we can machine with a short tool that will not create vibration. Okay. It will make a gouging move in these areas. So I open containment check tool and holder, and okay, and click generate. And click generate. So I can make a non-gouging move with a short tool and don't get a vibration. I used follow periphery, this simple method, but I can use a more advanced method here. I use steep and non-steep and use 20 millimeters. It means that in higher angles than 20 millimeters, that's steep surfaces, use this cut pattern and these values, and in non-steep areas between under 20 degrees, use these values. You can optimize as ZW profile. And we can see cut regions here. Like this. These red areas are inaccessible with this tool length, and this is a steep area and non-steep areas. Okay, and click generate. It makes very much engaged motions and lifting. We can minimize it with transfer rapids between regions, traverse and level save Z. We can minimize these lifting moves. Now how it works, let's examine it. It makes follow periphery, or you can change it to zigzag. Okay, and generate. You can change the steep, non-steep area cut pattern unlike the Z level. And it makes Z level moves, the profiling moves in steep areas and doesn't touch the inaccessible areas. Okay, I click OK, and now how will I machine these rest areas? I copy this and open cut regions again and import collision, create region list. I get these collided areas, I choose them and tool collision avoidance. I use a long tool to access here. Okay, and I have green colors that tells us there are non-colliding moves. Okay, and generate. When I look both, I can see that I machined all surfaces with first short tool that creates unliberated moves, and with long tool but very little area. It is all for contour area. It is a finishing operation that is used for non-steep surfaces, formed surfaces, unlike the Z level. It is the most common used operation, finishing operation in NX. It's all for this video. Thank you for watching. If you have questions, please ask me on comments.